Hi there. Now here we've got an example for you to try. If you've been watching my previous videos on partial fractions, you should be able to have a go at this one. Express x plus 2 all divided by x times x plus 3 times 2x minus 1 in partial fractions. So if you'd like to have a go at this, just give you a moment to pause the video. When you come back, you can either fast forward just to check out the solution quickly, or I'll take you slowly through the work solution. Okay, welcome back then if you had a go. Well, with something like this, we'll just start by copying the fraction down. What we've got in the denominator here is 3 linear factors. And I showed you that if you've got linear factors, they give rise to partial fractions of the form a constant, let's say a, over the first linear factor, which in this example is x, plus another constant, b, say, over the next linear factor, which is x plus 3, and then another constant, c, say, over the last linear factor, 2x minus 1. And to get a, b and c, what we need to do is multiply by the denominator here to each side. So if we multiply the left hand side with the denominator here, x times x plus 3 times 2x minus 1, it's just going to leave us with x plus 2. So x plus 2 would be identical to, and if we multiply this fraction with the denominator here, the x's will cancel and just leave me with a multiplied by x plus 3 multiplied with 2x minus 1. For this second fraction here, if we multiply by the denominator here, the x plus 3's will cancel, leaving me with b times x times 2x minus 1. And for the last fraction, multiplying this fraction with the denominator, it's the 2x minus 1 that will get cancelled, leaving me with c times x plus 3. So c times x plus 3. So we've got to work out a, b and c now, and we can do this by making each of these brackets 0. I say each of these brackets, but the first value I'm going to take is in fact x here, x actually equaling 0. So if I make x equals 0, we'll say when x equals 0, then on the left here we're just going to simply have 2. So we therefore got 2 equals, and here we'll have a times 3, okay, a times 3, and this will be 0 minus 1, so that's going to be times minus 1. So you've got 2 equals minus 3a, so if I divide both sides by minus 3, you end up with a equaling minus 2/3. Okay, so that's a. Let's move on and see if we can find another value. Let's choose x to be minus 3. It will make this bracket 0 and this one here 0, and it will allow us to find out b. So let's say when x equals minus 3, then we're going to have minus 3 plus 2, which is going to be minus 1. And that's going to equal, well, as I said, this bracket will be 0, so all of this will go out. Here we'll have b times minus 3 for that x there, and then 2 times minus 3 is minus 6, minus another one is minus 7. So we've got minus 1 equals plus 21b. So if I divide both sides by plus 21, I'm going to end up with b equaling minus 1 over 21. So there's b. All we've got to do now is just work out c, and we can do that by, say, letting this bracket 2x minus 1 equal 0. And if 2x minus 1 equals 0, 2x would equal 1. Divide both sides by 2, and then you get x equals a half. So when x equals a half, then we're going to have a half plus 2 here, which is 2.5. Be better written as 5 over 2 though. Okay, and that's going to equal, well, this will be 0, so all of this term will go out. This bracket will be 0, so all of this term will go out. And then we're just left with c times x, x being a half, multiplied with a half plus 3, 3.5, or better still, 7 over 2. So here we've got 7c over 4, and if I multiply both sides by 4, what I'm going to get is c equals 10. So we've now got 7c. So if I multiply these two fractions together, I've got 7 over 4. So we've got 7c over 4. Multiply both sides by 4, and I end up with 10 equals 7c. So therefore, if I divide both sides by 7, then I end up with c equaling 10/7. Now that I've got A, B and C, I can finish off. So let's just summarize by saying therefore, we'll copy the fraction down, x plus 2 all divided then by x times x plus 3 times 2x minus 1 is identical to, well, I notice that A and B are negative values, and rather than put them as the first two values, I can see C is positive. I'm going to start with that one, it will look better. So rather than have 10 over 7 all over 2x minus 1, I can rewrite that as 10 all over 7 times 2x minus 1. And now if I go back to the A value, I'm going to have minus 2 over 3x. Okay, that's that one. And then for the last term here, we can have b, which is minus 1 over 21, and we can write that in as minus 1 over 21 times x plus 3. So I hope you're able to get that. If not, that you've been able to see how it's done now. And that brings us to the end then of working with these linear factor types. In the next video in this series, I'll be showing you how to find out the constants when we have repeated factors.